Okay, yeah, welcome everyone. I guess we can start, better start on time because we have quite a busy agenda. So welcome to this final outreach webinar of the EU-funded Navigate project. My name is Ramona Gulde from Potsdam Institute for Climate Impact Research, and I am the manager of the Navigate project. And yeah, during this webinar, Navigate partners will present insights into how decarbonization can be accelerated in different sectors and how distributional impacts of climate change and climate change mitigation measures can be minimized. The webinar is structured in the following way. First, we will have a plenary part with two main blocks with different presentations. And after each of the presentation blocks, you will have some time, or we will have some time for your questions. So please, if you have any questions or comments regarding the research and the results presented, please use the chat function to comment and post questions. And after that plenary part, we will organize breakout sessions to which you are hopefully assigned already to the one you chose. And here discussions will focus on decarbonization of different sectors, namely industry, buildings, shipping and agriculture. Please note that this webinar will be recorded and published on the CNCC YouTube channel. And yes, and now let's start off with an overview presentation by Elmar Kriegler. He is head of the Research Department Transformation Pathways here at PIC, and he is leading the Navigate project. So Elmar, please, I hand over to you.
Yeah, thanks a lot, Ramona, and welcome to this webinar, which is about the key findings from the Navigate project. And the main topic we will discuss here when presenting these key findings is how to achieve a rapid, fair, and efficient transformation to net zero CO2 emissions, or to net zero emissions. And the conference of the parties in Dubai just concluded yesterday with lots of discussion how to assess and evaluate the outcome. But what is clear that the language in this final declaration is first heavily referring to pathways, mitigation pathways, for example, in terms of the emissions gap, what would be milestones in terms of reductions, particularly for 2030. There's this number from the sixth assessment report of 43% reductions relative to 2019. The net zero goal as such is also something that comes from the pathways. So this all shows us that the work and the research on 1.5 and 2-degree pathways and higher pathways is highly impactful for the policy community and for the debate. Right now, we have a lot of discussion in the context of the conference of the parties on what we could say about transitioning away from fossil fuels, which you find in the draft text, to reach net zero CO2 emissions in keeping with the science. That's also something that these pathways give information about. So I think it's timely to bring these results from Navigate to you, and the basic mission and basic objective of Navigate was to advance integrated assessment modeling and develop the next generation of integrated assessment models. And that is what we have worked on in the last 4.5 years. And that is that in the end, we also looked at in terms of what these advanced models can tell us in terms of deep structural change and other deep transformational change and other elements of the transformation. So what are integrated assessment models? We're talking here about detailed process integrated assessment models. So not the DICE class cost-benefit integrated assessment models, but detailed process integrated assessment models that resolve a lot of processes, both on the land as well as on the energy side. They are coupled energy, land, economy, and climate system models. They usually have a global scope, run until the end of the century, but there are also now integrated assessment models being developed on the national and the regional scale. And their goal is to assess policy-relevant climate change pathways and underlying transitions of energy and land use and socioeconomic activity. You find here two links. to the Integrated Assessment Modeling Consortium, which has a description of what IAMs are, and also to a model documentation. So, as I said, these pathways are highly relevant for the debate about climate action. I'm just showing you here two examples. That is on the left, key graphics from the summary for policymakers of Working Group 3 of the IPCC, results based on these outcomes of integrated assessment models, contrasting scenarios that extrapolate current policies or nationally determined contributions in orange, and these 1.5 to 2 degree, well below 2 degree scenarios in bluish colors. On the right-hand side, this is just published scenarios by the Network for Greening the Financial System, a network of central banks, which we are collaborating with to produce these climate transition scenarios for them, and which are tailored to a set of narratives that the network has put forward and which are now being analyzed by the financial regulators. So I think these are examples how integrated assessment modeling informs international climate action. There's the system level integrated assessment of mitigation strategies, including the milestones, benchmarks, and targets for policies. There is, in a scenario setup, an analysis of mitigation challenges along the way. For example, hard to abate sectors, investment needs, and interactions with broader societal objectives. And doing this work allows to contextualize current policy, socioeconomic and technological developments in terms of their implications, for example, for the implementation of the Paris Agreement. In order to do this well, it requires a constant improvement of these models. And there is the strong demand for improved policy relevance of integrated assessment. I'm just listing here a few bullets that this refers to: integration of missing processes, particularly relating to deep structure in transformation. It's an important one. More granularity, particularly in the sectors and when implementing policies. Broader and more policy relevant scenario design, for example, including equity in institutional considerations much more strongly than in the past. More frequent model and scenario updates, because those, the developments are happening rapidly, for example, in terms of policies and proposals, as well as implementation. Be realistic about the near-term trends and be transparent about not only the underlying model assumptions and the model code, but also about the ability to understand what these models can say and what they cannot say. So with that in mind, we started Navigate and categorized the improvements we were going for into three groups. One is usability, so increasing the transparency, accessibility, and relevance of integrated assessment models, and the main output, which is scenarios and mitigation pathways. The second one is transformative system change, so work to better represent transformative change in the economy, so that's structural change, but also in sectors, and that is then closely related to technological change. But we also looked in transformative system change on the demand side. So in terms of lifestyles, consumption, services, that was also an important work package in the project. And then the third topical area was really to better represent the heterogeneity of actors, not so much in an endogenous way looking into the strategic dimension, but really representing the heterogeneity when talking about distributional implications of transformation pathways. On the right-hand side, you can see the large consortium. It includes leading European integrated assessment models. It also includes domain experts on topics like transport, like buildings, like inequality and welfare, life cycle analysis, and these topics. So it was a well-selected and rich group of leading institutions that gave us the basis to really move the ball here. We also had two international partners, COPE from Rio de Janeiro, Brazil, and NCSC from China. The project was funded under Horizon 2020, and it ran from September 2019 to the end of this month. So it's really our last outreach event we're doing here. Now, before I wrap this up and hand over to the colleagues, let me quickly say a few words on this first aspect of usability, because we don't have a separate presentation on this one. So one thing we did is to further improve the IAM model documentation platform, which is a platform where you find next to each other documentations of many integrated assessment models. And the aim is also to do this in a harmonized.
Mark Noord, zal ik je mijn klantnummer even doorgeven?
Somebody please mute the microphone, because I just got some. So I'm back here. Can you hear me?
Yes.
Yeah. Okay. So let me wrap this up quickly. On the transparency side, what we included in this model documentation platform is some information about some of the input related assumptions like GDP and PPP, that GDP and population, that when looking at this model documentation, one can find a link to the scenario explorer, to the database, and look at those. So that was one example. We worked on the usability in terms of we had a publication on how to deal with large scenario ensembles, which particularly in the context of an assessment like the IPCC 6 assessment report, working with large ensembles of scenarios is pretty relevant. And then in order to increase relevance, we also had work on doing country downscaling, so that not only the information on these pathways were available on the native model regions or on large-scale meso regions, harmonized across models, but also downscaled on a country basis. All right, wrapping this up, we have developed a number of products and tools. They are highlighted here on this website, on this slide. On the left-hand side, you see that we produced a Navigate synthesis report with the policy relevant results, and we really encourage you to look into this synthesis report, which you find on the website. Here's also a QR code. And then our main platform to disseminate our results is the so-called Navigator, which has 3 pillars. The Learn pillar, where it's about webinar recordings, capacity building material from the summer schools we did. We have the Use pillar, where you find the actual scenario data that we produced in the end, and that will be discussed or will be center stage in what comes in this webinar. And then we have an Apply pillar, where the tools, data sets that we developed during the project can be accessed and downloaded, or documentations be found, so that those will then be useful also in the future for the wider community. This is the agenda for today. I've just given you an overview. In the first part, we will jump into system and sector transitions with 3 presentations. And then at the end of this, we have 10 minutes Q&A. Then we jump into the second part, which is on the equity, efficiency, and sustainable development side of our research. Again, 3 presentations, 10 minutes Q&A. After a short wrap-up, we do have a short break, 5 minutes. Now, idea was to also have breakout groups in the end, where you really can then discuss some sectoral transitions in greater detail. We have industry buildings, we merged the shipping and the road transport, and finally agriculture. And you, when you registered, already indicated your interest, so you will be, after the break, automatically then assigned to these breakout groups that you indicated interest in. So with that, I stop sharing and hand back to you, Ramona.
Yes, thanks a lot, Elmar, for giving this overview. And I will now directly hand over to Jessica, who will present first insights from Navigate.
Yeah, thanks, Ramona. Yeah, so it will be my pleasure to present you some of the results from the Navigate project. This is sort of a synthesis result, and I will stick with global and aggregate results, and you will see further details in the sectors in the following talks. So the main motivation we started out for the study was the observation that current climate policies are not consistent with the 1.5 degree limit. And the main reason for that is that current carbon pricing is not comprehensive, and it's also not sufficient, so the level is not high enough. However, a comprehensive and sufficient carbon pricing is indispensable already to stay well below 2 degrees. But since time is now so short and the budget for 1.5 degree is so small, we also consider complementary policies that target technological improvements as well as behavioral changes to further accelerate action on top of a carbon pricing to stay well below 2 degrees. And the question we try to answer with this study is whether these additional policies can complement the carbon price and accelerate action and close the gap between a well below 2 degree and a 1.5 degree scenario or pathway. So here we look at different measures that can target all sectors, and we start from a pathway that's consistent with current policies, and then we add a sufficient carbon price across all sectors that already takes us to a well below 2 degree scenario. And then on top of that, we add further measures that target, for example, technological transformation. So examples for that would be a push for more direct and indirect electrification in all sectors, so industry, transport, buildings, and also a significant deployment of CCS. In the second dimension, we look at measures that would aim to reduce energy consumption, and that comprises both efficiency measures like faster buildings renovation or better insulation for new constructions, as well as sufficiency, so things like a shift in set point temperature or reduced passenger and freight transport or modal shifts. And as a third dimension, we also not only look at energy measures, but also at land measures. And here we have both technical measures that reduce non-CO2 greenhouse gas emissions, things like peatland protection and restoration, but also behavioral changes like dietary changes or reduced food waste. So with all these measures, we look at how can they reduce global emissions in 2050. And I will now split up emissions into several parts and start with supply side emissions. So that's electricity, but it's also the production of other energy carriers like liquid fuels or gases. You see here in black the current policies, and then in colors the additional measures. And what we see here is that the high carbon price that we apply already fully leverages the emission reduction potential on the supply side. So here we don't see really any changes with this additional measures. If we look at the demand side, however, then you can see that the carbon price in the well below 2 degree scenario already takes us quite far, but the additional policies then contribute to further emission reductions on the demand side. So that was CO2 emissions, but we also have CO2 removals, and they're especially increasing the CCS capacities and when we add the technical measures, so the light blue scenario increases the CDR option, but also the land-based option enhances the CDR potential. And then if we extend our view beyond CO2 to the non-greenhouse gases, there we see that, again, a carbon price is essential, but then on top of that, land policies are really crucial to further reduce the non-CO2 emissions. Let's look not only on emissions, but also on further impacts on the energy system. And what you see here is the global electricity generation. In orange, red is total electricity generation. And then in green, you have the renewables, the variable renewables, wind and solar, and in blue, fossils. And this is just the well below 2 degree scenario. And we see here two things. One is that a carbon price is really central to push out fossil fuels out of the electricity generation. So this small blue bar of fossils is close to zero. You also see that we have a lot of variable renewables in the system. So they increase already by a factor of 3 by 2030 and by a factor of 10 by 2050. If we now add the technical measures that lead to a push for direct and indirect electrification in all sectors, then we can see that this, of course, leads to a higher electricity demand and especially to about 45% higher variable renewable electricity demand in 2050. So we need to expand renewables, and we need to expand them even more if we have more electrification in the system. But then if we, on top of that, add policies that focus on energy consumption, that reduce energy consumption again, then this balances the additional electricity demand. So here we really see that these measures are complementary, not only in terms of the emission reductions, but they also, in combination, provide benefits for the energy system. Now, the central outcome is not only what does that mean in terms of emissions, but also what does it mean in terms of global mean temperature? How far do we go towards 1.5 degrees? And what you see here is the peak temperature, and the well below 2-degree target, of course, stays median between around 1.7, 1.8 degrees. And the combination of all measures gradually reduces the global mean temperature to a level that's compatible with 1.5 degree with a low overshoot. And again, you see that it's really the combination of all measures that brings us close to the target. And that is even more visible if we look at the temperature at the end of the century in 2100. Again, we see that the combination of all measures is important, and especially land policies contribute a lot, simply because they not only add to enhanced carbon storage of land and therefore reduce cumulative net CO2 emissions, but they also target the non-CO2 greenhouse gas emissions, which is crucial in reducing both peak warming and also warming in 2100. So with this, I'm at the end. Just a quick summary. So we've seen that comprehensive and sufficient carbon price is needed to phase out fossil fuels and to reduce emissions both on the supply and the demand side. Policies focusing on a technological transformation are crucial for further decarbonization of all demand sectors by 2050 and to increase the carbon removal potential. Policies that reduce energy consumption are complementary, as they further reduce emissions and they reduce energy demand, and that not only leads to further emission reduction, but also balances the higher electricity demand that results from more direct electrification. And finally, land policies, they can contribute to enhanced carbon storage in land, and they are the most effective option for reducing non-CO2 greenhouse gas emission, which leads to a reduction of peak warming as well as end-of-century warming. And with this, I hand over to Nico.
Yes, thanks, Jessica. Maybe a short reminder for all those who joined a bit later. Please, if you have any questions or comments, please put them in the chat, and we will have 2 more presentations now. And after that, we will have a few minutes to take those questions. Nico, please.
Yeah, I'm getting into presentation mode here. Hello, everybody. Dun, 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 dun. Okay, I hope you can see it.
Yes.
Okay, so hello everybody. I shortly present you key insights from industry decarbonization. This was one of the key topics on the transformational side in the Navigate project, and we did a model comparison exercise where we looked at the global industry sector emissions and how to reduce them. So as a baseline, we use the current policies as they are implemented, and we would see a slight increase. It is lower than previously in the AR6 set of models, particularly because we have more baseline decarbonization, like with the electrification of industry processes, especially low temperature heat. when we want to achieve a well below 2-degree target, industry sector emissions have to be reduced by that amount, and the reduction rate, so the percentage reduction, is relatively similar to the global total CO2 emission reductions. So the share of industry basically does not increase. There's variation, yes, but the shares are not so much different in 2050, and the range is relatively small. And when we go to the 1.5 degree target, we need to reduce emissions much more aggressively. But the industry sector runs the risk to lag behind, and that the emission reduction rates are not as deep as the total emission reduction rates. So that suggests hard to abate emissions. However, there is models at the lower end of the range that you can see in 2050, and they share some common properties in that they have a huge portfolio and key technologies to reduce the emissions. So what we are now doing is we run through the different industry sectors. We have explicitly modeled iron, steel, cement, chemicals, and other, which is sort of conglomerate with manufacturing and others. And here I refer a little to total. In the emission reduction potentials are, for example, or the most discussed is electrification. The problem in the 1.5 degree case that we are facing at the total electricity market is that we reduce the fossil fuels very steeply, very rapidly, and at the same time need to ramp up green electricity, and all other sectors also want to electrify. So we get a very, very tight market situation, and not all the electricity that you may want to have is available. So the allocation then works like this. The secondary steel production can be electrified. The cement sector has a high potential for electrification, but only if it is combined with the CCS. This technology, however, is not mature yet and requires a lot of development. And then in chemicals and other sectors, it has a high potential for process heat production to substitute fossil fuels. Hydrogen and e-fuels, we see that the market expansion is relatively limited because of the tight electricity market in particular. So in the steel sector now we have H2 DRI, whereas in the cement sector hydrogen hardly plays any role. In the chemical sector it has a huge potential as a feedstock, and in the other sector also a huge potential for heat. Bioenergy, this is versatile substitute for fossil fuels, but a limited supply. And when you are relying on bioenergy in particular, or in the 2-degree case, there is not much room for expansion, further expansion of bioenergy. So in the iron and steel sector, there is not much to expect. However, in the cement sector, as a heat source, in the chemical sector, it can be important as a feedstock, and in other sectors as a heat source. So feedstocks can be quite prominent, especially if demand is very restricted. CCS has especially a huge potential for the process emissions in the cement sector, and there, especially if we have electric heating included. In the chemical sector, it's also relatively high. In the steel sector, not so much, mostly transitory. So up until 2030, you can see some investments, but not further. Then material reduction and recycling. can have huge potentials, but it is regulatory intensive and governance intensive. With the residual fossil fuels, particularly in the chemical sector, we may see 20 down to 15 barrels per day, a million barrels per day, excuse me, whereas coal use in cement and iron and steel would phase out. When we now have huge potentials to lower the emissions in the industry sector, we would see less distributional conflicts between regions, because we can have lower per capita emissions, and the dots here are different models and the different scenarios. The green one are the 1.5 degree. The variation between the regions decreases. Yeah, but this is only possible if you have enough flexibility, enough mitigation potential to reduce the global emissions. Then the distributional conflict between regions becomes smaller. Also, it avoids CO2 price inflations and can keep the CO2 price in 2050 limited. It reduces the need for carbon removals, and it helps to overcome the residual emissions and to keep the door open for the 1.5 degree target. Thank you very much for your attention.
Thanks a lot, Nico. Okay, with that, I hand over to the last presentation of this block to Rik van Heerden from PBL, who will say something on the role of demand-side measures in climate change mitigation pathways.
Yes, thank you, Ramona. I will present to you the multi-model intercomparison study that we did on the role of demand-side measures in climate mitigation pathways. More specifically, we focused on the buildings and the transport sector. And those sectors are responsible for 8% and 26% respectively of energy-related greenhouse gas emissions. And not only that, but they're also responsible for about 50% of the indirect emissions resulting from electricity and heat generation. In the most recent IPCC report, it was already mentioned that sectoral greenhouse gas emissions reductions are possible by 2050 of about 40 to 70%, which is quite large. But there are still also large uncertainty about the exact amount and also in which way we should achieve this. So the objective of our study was to explore the emission reduction potentials of demand-side measures in the sectors that I mentioned, and more from a system perspective that we can provide using integrated assessment models. And in particular, we wanted to focus on what is the most optimal strategy to achieve these reductions. So to start with, we held a stakeholder survey in which we asked experts in the field what they consider to be both feasible but also highly impactful measures to do in the buildings and the transport sectors. And based on this stakeholder survey, we compiled a set of measures that we wanted to consider in our scenarios, and we split them into 3 different strategies. The first one is about activity reductions and shifts with measures such as flexible use of buildings, but also more car sharing and carpooling, for example. The second strategy is about technological improvements, which focuses more on improving the efficiency of already existing technologies, for example, through building codes and standards, but also in the transport sector, efficiency standards for passenger vehicles, for example. And the third and last strategy is focused on electrification and fuel shifts, and that considers more drastic technological changes. For example, full electrification of passenger vehicles, and where electrification is not possible, increased use of biofuels and electrofuels, just as examples. So for all of these strategies, we constructed a scenario, which gives us 3 scenarios. We also had a reference scenario without explicit demand-side measures and a scenario in which we combined all the measures explicitly. And next to this, we consider two different climate ambitions. One for which we assume current national policies to continue. And in the other one, we consider a global effort to limit global warming to 1.5 degrees Celsius. And in the presentation today, I will only focus on the first one, the scenarios with current policies implemented. We implemented these scenarios in 7 different IEMs, and they're on this slide. So let's go to the results. First, I want to show you what the implications are for final energy demand. And these graphs show the change in final energy demand relative to 2015 in both 2030 and in 2050. And from left to right, we see the different strategies. The leftmost one is the reference scenario in blue, and then in following order, the activity focus scenario, the technological focus scenario, the electrification focus scenario, and the scenario that combines all the different measures. And what we see is that actually all the strategies reduce energy demand compared to the reference, but still there is an increase with respect to 2015. On the contrary, the scenario that contains all the different measures has a much larger effect, and for many models is also able to reduce the final energy demand compared to current levels. So next up, direct CO2 emissions. We also see here that all strategies reduce emissions. And here we clearly see that the largest reductions are actually caused by the electrification focus scenario, particularly in 2050. And it's important to keep in mind that these are direct CO2 emissions because, of course, there's also a lot of electricity demand increase in this scenario, but that's not considered here. And we see similar patterns for the buildings and the transport sector, both in 2030 and 2050. So here I plotted in a different way, not compared to 2015 levels, but we compare here the strategies to the reference, and then we see again that the electrification focus scenario has clearly the largest reduction potential, particularly in 2050. And also we see that the scenario that contains all the different measures has about 60 to 70% mitigation potential compared to the reference in 2050, which is quite large and also reasonably in line with the IPCC results. Also, we see a bit more model spread for the transport sector than we see in the building sector. As I already mentioned, electricity demand can be a huge issue, especially for the electrification focus scenario. It requires increased generation, storage, and grids, etc. And here we see that both in the current policy scenarios and also in the scenarios that limit global warming to 1.5 degrees, there is indeed a huge increase in the electrification focus scenario. But on the other hand, the other strategies, the activity focus one and the technology focus one, reduce electricity demand quite a lot. And by combining them, we can help. This helps to mitigate this rapid increase in electricity demand, as we can see in the scenario in orange, which combines everything. So that brings me up to the conclusions. Demand-side measures can reduce direct emissions by 60% for buildings and 70% for transport by 2050 compared to the reference. And we also found that there is not really a single ideal strategy. Electrification has the largest impact on emissions, but it also increases stress on the electricity supply side. And therefore, combining different approaches is beneficial. It further reduces emissions, but also alleviates distress to some extent. Thank you.
Thank you, Rik. Well, as I said, you're welcome to pose any questions and comments you have in the chat. I'll give you a minute or so, maybe. So far, I haven't seen any questions. So if there are none, I suggest we move over to the second block of presentations. And for instance, on industry decarbonization and buildings decarbonization, you also have the possibility to ask more in-depth questions or have discussions on that in the breakout sessions later in this webinar. So yeah, since I don't see any comments or questions, let's move to the second block of presentations. They will revolve around equity, efficiency, and sustainable development. And Johannes Emmerling will start from RFF-CMCC on distribution implications of climate policy and impacts. Over to you, Johannes.
Yeah, thanks, Ramona, and good day also from my side. I have been working with all the colleagues in the Navigate project on the second block that Elmar mentioned at the beginning, which is kind of the people dimensions, using the similar tools that also have been used in my preceding speakers. And in this work package, we looked at distributional implications of climate policies and of climate impacts. So looking at inequality and what parts of populations are affected by policies or potentially by climate impacts. And I will present here just an overview of the main results. So we looked into basically the role of heterogeneity in populations, issues like inequality and poverty, the role of carbon revenue redistribution and how it can enhance distribution implications, and also a combination with climate impacts, which we'll then hear also afterwards. And here what we did is basically the main work was a model comparison project, and actually the first of its kind, where we used 8 very different integrated settlement models to assess the question of distributional implications of climate policies. So just a few other results that we had in the project. So I think a very interesting result for Europe was focusing on what is the distributional incidence of carbon pricing, in particular in Europe. And here you see just that basically looking at household deciles. So here you see the household deciles in selected European countries, and basically showing here, for instance, the case of a $25 carbon tax, showing that basically poorer deciles, so especially the first 1 or 3 deciles, the poorest 30% of the population, typically share a higher burden in terms of their expenditures when a carbon price is introduced. And this really indicates that climate policies have regressive impacts, and therefore this needs to be taken into account for policy design and potential redistribution. Now, this one has been more like an empirical or simulation exercise. And what we then did in the study is to look at how does this expand also to the global level. So looking at several other countries, and here for instance, we estimate how climate policy incidence varies with GDP per capita or income, finding typically a value lower than 1 for the income elasticity, meaning that poorer households will have a relatively higher share of policy costs, and then really that is an issue for policy design. And we also have secondly integrate impacts, because of course also climate impacts are not affecting everyone, and also this we've seen in the latest COP that of course some countries that are more exposed, but also within countries there might be the incidence is not equally distributed across individuals. And here we did an empirical study, basically looking again at household deciles. So in this work package, basically we always look at the deciles as kind of the separation of the population in each country. And here we estimate, for instance, the climate impact across a large set of 160 countries, and always looking at the decile in each country. So this is the poorest 10% in each country, and we find, for instance, here the climate impacts by the end of the century in an SSP 3 RCP 7.0 scenario, kind of a baseline scenario, is higher for the poorest decile than for the richest one. Especially when we find that we have, interestingly, for the richest, it's almost 0, can even be positive, meaning that really impacts are heavily regressive, and this of course has important implications for policy design. Now coming to the main implication, where we take these empirical results and we have implemented in 8 different models in 10 countries. Each model in their own way implemented distribution implications and within country inequality. we have then the three basically scenarios. We have a climate policy, the first row in red. Then where we basically just have the climate policy. Here we focus on a 1.5 degree target. And where we see that basically here we only look at the Gini index, and we see that typically it slightly increases by around 0.1 or 0.2 points across the world. The second row then is when we say now we take the carbon revenues and we redistribute it on an equal per capita fashion to all households, at which it becomes basically negative, meaning that inequality is reduced. So by up to 2 points, especially in developing countries, indicating that really redistribution can, especially here on the left in 2030, really make inequality even decrease compared to a reference case, because we are redistributing household, especially which matters for poorer households, of course. Over time, this effect dissipates because carbon revenue kind of dry up, but in the short term, we find that this is really a strong impact for where basic climate policy can be also an inequality improving policy if we have this redistribution. If we then also add climate impacts, or basically saying what happens on the avoided climate impacts that we basically avoid by focusing on 1.5 degree target. In the short term, there's not a big difference because, of course, impacts are lower in the long term. But in the long term, we find in this case, compared to the climate policy case, that also here inequality is lower. Meaning that in the long term, really climate impacts, because they're also regressive, as I showed before, lead to a reduction in inequality. Meaning that in the 1.5 scenario, the world is not only cooler in the sense from the climatic point of view, but also less unequal, because we avoid this increase in climate damages which hit the poorer more severely. And this effect dominates even the climate policy redistributive effect, or the climate policy redistributive impact. And this, I think, is a key result here. We also can then look at this more across different countries, and we find here on the right side is more relevant for developing countries, which are more to the right, where the effects are larger, simply because there's also a larger poverty, and carbon revenues can have a bigger impact on redistribution. And finally, we also look at kind of the welfare measure. So here we take the welfare measure based on the Amartya Sen welfare function, which takes into account not only inequality, but also the impact on the economy, on the macroeconomy. And here we find that while indeed the climate policy implies policy costs that can go on average 2 to 4% of welfare, however, it increases in the short term with a redistribution. So here we have a positive immediate effect if we take this money from carbon revenues and we redistribute it to households, especially poorer households, which with equal per capita can be a good threshold. In the long run, however, welfare is by far higher if we also take into account avoided impacts. And here we have two effects. The one that basically GDP loss is by far removed, but also we have a gain from the inequality, leading overall to a gain by 3% on this welfare measure by 2100. Yeah, this is basically just showing that this also has big implications, of course, for who gains and who loses from climate policy. And here we find that exactly this equal per capita dividend can really already lead to a 2/3 kind of approval of climate policies, because households will receive the money that is collected through carbon pricing strategies. So we think this is really a key result in the short term. And with that, I think I'm concluded. And yeah, I think maybe the questions we can collect at the very end of all the presentations. Thanks.
Yes, thank you, Johannes. Yes, again, the invitation to, if there are any questions or comments, please put them in the chat, and we can discuss them after 2 more presentations. And now next, Panagiotis Fragkos will present insights on socioeconomic impacts of different types of recycling revenues from carbon pricing. Over to you, Panagiotis.
Thanks a lot, Ramona, and I hope now you can see my
Yes.
slides.
Mm-hmm.
Great. Yeah, and now we turn into a similar theme, but looking a bit more broadly. So the overall socioeconomic impacts of net zero pathways. And we aim to explore the impacts of ambitious decarbonization on macroeconomic indicators. For instance, what happens to the overall economic growth of a country, investment, etc., but also the employment change, which is quite important, especially for policymakers. And the analysis also will show how we can ensure double dividends from mitigation, in particular, exploring different ways to recycle the carbon revenues that are collected by the government. So in order to address these research questions, we applied 4 leading macroeconomic modeling frameworks, which are, let's say, most advanced in the field and are very much used by in research and policy discussions. And 3 of them are computer general equilibrium models, IMACLIM, GEMI3FIT, and the JRC GEMI3 model. And also we have a macroeconometric model, which is E3ME model from Cambridge Econometrics. And these 4 models, they, let's say, represent the entire economy. They have quite a lot of similarities in how, for instance, they represent technological change and the labor market, etc. However, they have a very big difference, which is related to how they represent the issue of capital and whether they assume that whether capital resources are unlimited in the economy, so they can be freely used, for instance, to finance investments required for decarbonization, or whether these resources are quite constrained by the available capital in the economy. So this means that decarbonization investment may cause a crowding out effect in other sectors. So this is their most important difference, and as you will see, a major driver of the results. So first, we explored the net zero scenario, basically in line with the 1.5 Paris goal with these models. And you can see here that despite the fact that on the overall aggregate level, the GDP impacts may be small or moderate. However, if you dig deep into specific countries, which these models can actually represent, we can see that there may be some regional disparities, especially with countries facing large negative impacts, countries like the ones that are major fossil fuel exporters, so there is a lot of energy export revenues, but also countries that currently have a very carbon intensive production structure. So this means that the carbon pricing imposed on them will have detrimental effects on their economic growth. However, on the other side of the coin, fossil fuel importers tend to face more modest GDP impacts and even positive, especially in the case of the E3ME model, which has this assumption of unlimited finance supply. Disparities also, we can see disparities also in the level of sectors. So there are clear winners and losers. So in the winning side, we see of course, the electricity supply. As Nico mentioned before, electrification is the most important, or one of the most important decarbonization strategies. Also, the winners are the construction services, because these are required to build the low carbon technologies and infrastructure, and also sectors that manufacture the renewable goods. Finally, agriculture, especially when it comes to advanced to biofuel use, is also on the winning side. Of course, on the losing side, there are sectors that are related to fossil fuel supply, all fossil fuels, so both coal, but also oil and gas, and for instance, in the entire supply chain, so starting from oil and gas extraction to refineries and their transport, plus also the energy-intensive industries. And finally, there are sectors that are not clear. The outcome, it depends a bit on the model, specific modeling results and the assumptions that we have, like services or other other industries that are not very energy intensive. So the second stream of work, we tried to assess ways in order to recycle carbon revenues, because this can be an important revenue source for the governments as years pass, and as Johannes showed before, this will be quite important, especially if carbon price increases a lot. So the literature focus on two main reallocation schemes. The first is to use these revenues in order to reduce distortive taxes in the economy, and most importantly, labor taxes, which are quite distortive. And the second is to use them for lump sum transfers to households on an equal per capita basis. So again, we use these four well-established multi-sectoral models to assess these two key options in scenarios that are aligned with the Paris goals of well below 2 degrees and 1.5. And as you will see, we'll focus both on the efficiency side, so the cost impacts, but also on equity impacts of these recycling schemes. So first, on the GDP impacts, and here you can see the results of only the 1.5 degree scenario for GDP and employment in the two different revenue recycling schemes. And the most important finding is that when we use carbon revenues to reduce labor taxes, this is beneficial for the economy as it reduces around 40 to 70% of GDP losses. So it really matters a lot how, if these revenues are reduced if these revenues are used to reduce labor tax, because it can be very beneficial for the economy, it can boost productivity, and also create new job opportunities. On the other hand, the lump sum transfers to households may be good for equality, of course, as we've shown before, but this misses some opportunities for enhanced productivity and job creation, especially in the models that are resource constrained, like CG model, like in GEMI3 and IMACLIM, where the resources are a bit constrained. The labor scenarios, of course, increase a lot the labor demand, and especially in some models like GEMI3 and D3ME, this can even lead to double dividends. So environmental impacts, so emissions going to net zero while creating more jobs in the economy. So this can be very important finding. Then we also assess the impacts on the equality with assessing the Gini index and how this develops in different models and scenarios. Of course, here the situation is that the lump sum transfer policies leads to progressive outcomes and large Gini index improvement, especially in developing countries, where because these countries tend to have higher share of carbon revenues as a percentage of their GDP, so they can use all this money, the government can use all this money to improve equality. On the other hand, the labor tax scenario have smaller equity impacts, and this depends a bit on the country. So they can be either progressive in some countries, like India, China, or regressive, like the EU, but really they're more limited. So overall, there is a clear trade-off that we find between equity and efficiency. And here it's very important to have balanced packages in order to have well-designed climate strategies that actually can balance between equity and efficiency, depending also a bit on the national context. And final slide is the impacts on the EU, taking a very specific look in the EU. So what we see is that the GDP impacts in 2040 are a lot lower than the global ones. So we see, for instance, models around +1% of GDP or around -2% of GDP. And again, you see, of course, that the recycling scenario is the one that produces more positive economic impacts. In terms of employment structure, we see that there's overall a net positive effect, as we described before, with around 1.3, 1.4 million new jobs created compared to the reference scenario. Most of these jobs are created in industries like construction, electricity, clean energy, but also a lot in the service sector, because the service sector is quite huge. So it's, let's say, it is influenced by the overall dynamics of the economy. So more jobs can also be created in that sector as well. And that's it from my side. And yeah, back to you, Ramona.
Thank you, Panagiotis. Okay, so we will have one more presentation by Isabela Schmidt Tagomori from PBL, who will share some insights on synergies between climate, land, and energy and water related SDGs. Isabela, the floor is yours.
Thank you, Ramona. Let's share. Yeah, Yeah, thanks for the introduction. In my presentation, I'm gonna talk about this one specific study that we did for Navigate, where we tried to exploit the synergies and the trade-offs between the 2030 SDGs, or the Sustainable Development Goals agenda, and the Paris Agreement climate goals. And the main goal of this study is to try to understand the synergies and the trade-offs between climate policy and the SDGs agenda. And we try to address how the short-term action on the SDGs influence the long-term climate goals. So we focus in this study, first of all, in the climate, and then in the land, water, and energy nexus. So comprehending the set of 4 Sustainable Development Goals. And in order to do that, we implement different measures connected to the different SDGs. So for instance, for SDG 2 on zero hunger, we implement healthier diets. So based on the EAT Lancet diet, so basically reducing the consumption of meat and increasing the consumption of vegetables. We also implement a reduction in food waste in primary processing and in consumption stages. And we improve the equity in food availability, so more equitable distribution of food across regions. For clean water and sanitation, we improve the efficiency of water use for irrigation, power generation, and industry, and also the environmental flow constraints. For affordable clean energy, we try to maximize the access to electricity and minimize the use of traditional biomass and coal for cooking and heating. And for life on land, we map and implement a protection of natural areas. And of course, the climate action, we try to limit the increase in global mean temperature, in this case, focusing on a well below 2 degrees. And these are the 3 scenarios that we work with in this exercise. So first, SSP2 reference scenario, then a climate scenario where we don't have any additional efforts on the SDGs, but we do have a climate target, so focusing on a 2-degree scenario. And then finally, a third scenario where we implement additional measures to achieve food, water, energy, and biodiversity targets. All of the scenarios that we have here include climate impact. So first, we assess the effectiveness of actions on SDGs. And here we did this study with 2 different models, so with image and with message IX-GoBiome. And in blue, you see the results of the purely climate scenario when compared to the reference. And in pink, you see the results for the SDG scenarios. So for the scenario, including the measures focusing on the SDGs. And what we see basically is how the diet changes have a very important role in reducing population at risk of hunger. So we see how having diets that focus on the intake of less meat and more vegetables, and also combining that with reductions in food waste, how much that reduces population and risk of hunger, especially in regions like Latin America, Africa, India, and other Asian countries. Then it's important then to highlight also that not only synergies, but we also identified trade-offs. So this result was only possible because we try to ensure that the distribution of food is more equitable around the region. And we see in our results that without that measure, healthier diets, they might actually end up increasing food insecurity. So highlighting that the challenges of this transition and how measures need to be applied to be combined in order to try to maximize the synergies and also minimize the trade-offs. When we evaluate the SDG on water and clean water and sanitation, we see how we have a reduction in water withdrawals that is basically a result of this efficiency improvements in water use in agriculture, power generation, and industry, but also in the environmental flow requirements that strongly limit water withdrawals in regions like the Middle East, Northern Africa, and Central Asia. In terms of clean energy and affordability of energy, we see that for the SDG scenarios, we have relatively lower energy prices. They still increase when compared to the reference, but lower than what we see in the purely climate scenario. And we see a significant reduction in population relying on solid fuels as well. And finally, for life on land, we see this dynamic where we have an increase in the share of natural land and a decrease in the share of cropland that is also connected to the changes in diet, of course. And that is a proxy for us to evaluate improvements in biodiversity protection. So we see how much, especially for the SDG scenario in 2050, how much more natural land we have because of ensuring this protection of natural areas. And finally, looking into the climate and how they connect. So we start the action, and here it is connected, but we could also argue that early leads to positive effects in pathways in the future. We see here how for both models, for image slightly a bit more, but how we see that the scenario where we have implemented the measures to focus on the SDGs agenda, we need to last in the longer term. So we do think, this range of technologies that might be, controversial. So in conclusion, we see the fact that combining, we see that near-term action SDGs has positive impact on achieving the long-term climate goals. We see reductions in solid fuel, preservation, natural land, and of course also city. We also see improvements to and affordability of electricity. Combining affordability and the shift healthier diet and reducing food waste, positive impacts across multiple SDGs, increasing security, benefits to sustainable water management. This transition, however, is still enormously challenging, and implementation of measures needs to be carefully addressed. We need to focus on the synergies and try as much the trade-off. We see, for instance, that if we simply shift towards less carbon-intensive diets with ensure equitable food distribution, the increases in food prices due to the pressures in the land system would in fact lead to higher food insecurity. So combining this is crucial for us to achieve the goals collectively. And finally, in terms of the climate policies and their combination with the SDGs agenda, see how we result in a smaller temperature overshoot, and consequently, this meets the negative emissions by the end of the century to meet the same climate goals. So both pathways reaching a 2-degree, but if we address that early on, meets the negative emissions later to compensate for the overshoot. And between the two policies, and we see how short-term action really helps achieving climate goals. Thank you.
Thank you, Isabela. All right. Since I haven't seen any questions in the chat or comments, I also invite, all the participants, if it's easier for you, or if you have any questions right now that come to your mind now, you can either, of course, put them in the chat, or if you want, you can also raise your hand and say your question or your comment. And if not, maybe I can have one question to the speakers. All the speakers that, or all the colleagues from the Navigate project, I mean, what do you think? Do you think the new generation of integrated assessment models is better suited to inform questions related to the next global stocktake? So both with regards to sectoral transformations, but also with regard to just transition. Maybe if some of you want to answer to that, please raise your hand. Any of the speakers who just presented some insights? Nico.
Yes, nobody wants to get forward. I do. I mean, the improvement of models has been always a task for integrated assessment modelers. I mean, this is absolutely usual. The interesting thing is what we can observe and what we can, what we learned over the years, improving models in various directions and various areas. And usually, or I would say, we discovered more and more potentials to reduce emissions, to produce carbon removals, or to include and integrate carbon removals. And that allowed us to kind of really tighten the long-term climate target also. The stiffness of models 10, 20 years ago was much, much larger. And now we see what are the potentials. And we see that we can go down with emissions quicker, with the net emissions quicker and deeper. So the higher resolution showed us more potentials. It also referred to some very, very hard to abate stuff, like the feedstocks in the chemical sector. Yeah? I mean, this is where it gets really hard. However, we also had the carbon removal part. Yeah, and I think this is, we brought the models forward. There is lots of work still to do. I mean, we have this other sector in the industry. Yeah, and there's lots of processes going on, and the uncertainties are very large with the residual fossil fuel use. What can you do there, and the diversity of all the different things that can be done. I think what needs to be more done, what is special for the sectors in different regions, to combine regions and sectors. This is where we really should probably invest more for the next global stocktake that also gets then more into the details. Yeah, thanks.
Thanks a lot, Nico, for sharing your thoughts on this. I have one question in the chat now from Rik van Heerden at UCC to Johannes' presentation. Johannes. So Ulrike is asking your study on regressivity of climate damages within countries is impressive, and they cannot really be compared to previous studies. So how confident are you in this finding, or how robust are the findings? She is wondering, and what additional or studies you think are needed to gain more confidence in these findings? Thanks.
Yeah, thanks. A good question. So I think, I mean, we put a lot of effort to try exactly a large number of models, and we did not do a lot of harmonization. So we really wanted to get all the model teams working on this same question, and then harmonizing and summarizing these insights. And there is some variation that we see, and that is indeed more in the paper. But so I think overall, we found there's quite some agreement on several points. I mentioned the point on the short-term potential on redistribution, on the long-term impact part. I think it would be one important way forward, a bit going also to what Nico said, would be the integration of sectors and the impact on different households. I think that's also important. Look at transportation. We see large disparities also in transportation requirements, heating, building stock, etc. So there, I think it all would be very, very nice to combine the sectoral and the distributional approach. In terms of making the results more robust, frankly, yeah, I mean, we have quite some model uncertainty covered here. Yes, that would be something to think about more in the future. I think in the detail, looking more at the sectors and what affects households and what types of households more differently, looking at the land urban-rural divide also, for instance, including gender inequality, is something that we started looking into beyond inequality on income, and that's also important dimension. So yeah, a lot of ways to go for the future, I think, to make it even more to improve the knowledge base here. But yeah, I think we had to start at this direction at least.
Yes, thank you, Johannes. Okay, then I will hand over to Elmar Kriegler for the wrap-up.
Yeah, thank you, Ramona. Could you start my video from the host side? I'm not able to do this one. Here we go. All right, great. So, we have given you a wide range of presentations, 6 different topics. I hope it wasn't overwhelming, but it shows the richness of topics that are being covered now by integrated assessment modeling. And it's also important to get an integrated assessment of the implications of these transformation pathways to be able to look into all these dimensions and try to increasingly integrate them. I mean, Johannes, you made this important point that trying to integrate a bit more the sectoral transition with the question of distributional impacts on income, but beyond that, also looking into distributional impacts on different societal groups, urban-rural divides. Like this is a very important topic. The key messages, some of the key insights we developed, just let me summarize here quickly, is that as we improve the representation of reduction measures and carbon dioxide removal measures, we can get deeper in the sectors, including the hard to abate sectors like industry. The demand side changes play an important role, but really what we need to have is to have these demand side measures work in concert with the supply side measures to estimate the full potential. Carbon pricing, as we have seen in this synthesis study presented by Jessica, is an important key element of these strategies, and then would be augmented by other policies to get even deeper. So there is scope for getting deep and rapidly deep, but it requires a lot of investments, and that will be, I think, the discussion going forward. We have also seen that due to the regressivity of climate impacts, in the long term, there will be large benefits for future inequality or for future equality if you can avoid these climate impacts and can avoid these climate impacts as drivers of future inequality. In the near term, if you imply redistributive policies, then we can also buffer and even overcompensate some adverse distributional impact of mitigation policy. So there is also a clear strategy here to move towards just transitions. So I think these results are encouraging. The question is, of course, about implementation, and I think that will be the challenge for the next, for this generation of IAMs and the future one, to inform the policy process in a way that is helpful for policymakers to progress on the implementation together with other actors like business and society.